Hey guys, today we're going to be talking about crimping large gauge wiring. Today I will show you guys a variety of ways of hooking up large gauge wiring, and we're going to be crimping it but using different styles for different situations. Now, it doesn't matter if you work on custom 4x4s or custom muscle cars or pro touring cars or even commercial vehicles. Whenever dealing with high draw electrical devices, we're going to have to deal with large wires and how to connect them properly to each other and also to the batteries. Now, this custom 1969 Camaro is a perfect example because it actually has quite a bit going on for it. So we can see that we have two batteries in here. So it has to be hooked up to a battery isolator. We have multiple amplifiers. There's actually 3 in this setup. So there's one behind, and then we have 2 more up here. And then we have a distribution center over here that's all serviceable hooked up to this battery. So this battery runs our audio, and this battery over here runs the car. We're going to be showing you guys a variety of ways of making connections, and this car is interesting because it shows several in one shot. So we have Ferrule connectors going into our amplifiers. We also have them going into our power distribution, but then we're also using lugs over here for our distribution power hookups to the battery itself. Now, dealing with any kind of wire, we always want to have the best possible connection, one for safety, performance, and also looks. But when it comes to thicker wire, this is where things get more serious because we're dealing with more amperage. So we have to have the proper tools. So here, this is what we typically use: a hydraulic crimper. I still use a hand crimper for certain situations. I have wire cutters. These cutters I just use specifically just for cutting the wire. I find these are really great and easy for making a clean cut and even cutting back the insulation. I also have a ferrule connector here. So when we examine wiring, we have different types. So this is what we typically see when it comes to battery wiring. So the jacket, if we were to compare it to what we use for amplifiers, the jacket is significantly more stiff. The strand count is typically less and they're more coarse. So when you have battery cable, it's just harder to work with. This is meant to be under the hood to deal with abrasion. It's not supposed to, but it is more resistant to it. It's just tougher and handles heat really well. Amp wiring can be used in those situations, but not all amp wiring in the aftermarket is made equal. Sometimes it's copper clad aluminum, sometimes it will be pure copper. Obviously, we always want to use pure copper, but also the jackets may or may not be rated to deal with oil or any other types of chemicals under the hood. So if you're doing battery connections, you want to use a specific battery cable wire. So you can get this from your local automotive store. I've seen people use welding wire, but I would just use product rated for automotive use. Now, when you're dealing with running your amp wire, this is actually better to use because it's so malleable, it's easy to work with. And this is where when you're running through the firewall, you're making lots of turns, this is what you want to have. So different products for different applications. So let's talk about the connectors that we're going to use. So typically what we're going to see in the aftermarket world is a ring terminal like this. And there's a variety of ways you can crimp it. You can use the hydraulic crimper. I'm going to show you guys how to, since I'm using the hydraulic crimper on other connections, I'm going to show you guys how I use this particular one in a vise. I do not put any of these in the vise. So I just want to give you guys a variety of options how you can do it. So this is really good on the interior vehicles, let's say for a ground. The downside to this being if you're using it outside, if you crimp it, I recommend soldering and putting dielectric grease on it because it is open, you're going to expose it to the elements. These jackets do work. Sometimes they're tight, sometimes they're loose depending on the brand or where they're manufactured. So tread lightly with that. I would prefer to see some sort of shrink tube with glue on it just because the glue helps hold it on. Now, if it's a power wire and it's going to be serviced by anyone, like it's easy to access. Now, a lot of our custom cars, a lot of our wiring is hard to access and we'll use red wire. Sometimes if it's blue wire, you might want to use red shrink tube on there just to help other people identify that it is a positive wire. Now for the extra vehicles, we'll typically use a lug like this. So it's 100% copper, and what you'll do is you want to strip back as much of the wire as possible and you want to really jam it in there and then crimp it on. And if you want to go the extra mile, put a little bit of dielectric grease. I don't like to put too much because then I feel like you're defeating how much friction it has the ability to grab. So I might just put just on the tip, but it's really more about your crimp. And then use some sort of shrink tube again with glue, that's going to help seal it. You don't really have to use the dielectric grease if you are using the shrink tube with glue. It just depends on how many layers of protection you want to give the wire. And then we have what we call ferrules, and this is what we use when we're dealing with set screw connections. So you can see most amplifiers will use some sort of set screw in order for the wire to be held into the amplifier. So let's just pretend this is the amplifier. It goes in, put the set screw, holds it. Works pretty good as long as you're using high quality wire. I really recommend you guys use 100% copper wire. Don't use CCA copper clad aluminum. I've just had way too many issues with copper clad aluminum in the past. At the new shop, we never use it anymore, and our warranties are next to none because of that. Now, looking at the set screws, you really have to observe, and they're not all the same. So this particular one has an edge to it, and on cheap wire, especially on speaker wire, it can really cut the wire and break it apart. This is where ferrules come in, because it will hit the metal and it'll create a crimp instead. So you can crimp these in larger applications like 4 gauge. I'll just use the crimp, but I'll show you in larger gauge situations, I'll pre-crimp it before I put it in. So you have to kind of tread lightly with what you're comfortable with and what it actually is doing, because you can't apply the same techniques to every single product depending on what the metal's made out of, because these smaller ones crimp a lot easier than these larger ones. Also, when you're dealing with battery wiring, they're not going to crimp the same compared to the amp wiring, the high strand count versus the low strand count stuff. Now, when it comes to fuse holders, I don't use ferrules in them. I'll put dielectric grease on the wire, and then I'll put it in, and then I'll just snug it up. The reason being is I just think the assembly gets really long. I just don't see the need for it. And then you have to really seal here because this has a gasket. Then you have to like dielectric grease this. Then you have to make sure that that's sealed, or you're gonna put shrink tube on it. So it's for a generic amp install. I don't use these on the exterior, but we typically use really good fuse holders, so I don't have to worry about that. Also, on applications like this is for this is more of a weatherproof design. You can see that this has a gasket on here, and then you have your mini A&L fuse up here, and it's got mounting tabs. I really like this piece when you're using on Sea-Doos or even semi-trucks. And you can see the distance from here to here is quite far from the fuse. Everything's plated, so it's gonna last long. You can take this apart, put a thin layer of dielectric grease on the contact points, put it back together, and it's gasketed here. I just don't see, like, the ferrule just doesn't work that well in this application. So don't just think like because you see items like this, you should use it on every single application. You kind of have to examine the products you're working with and then mix and match appropriately. Okay, so let's do the good old-fashioned ring terminal with a vise, because maybe some of you just need to make a connection, you need it to be safe, but you don't have a means of purchasing these tools or for whatever reason. This is probably the most controversial way of doing the wire hookup, but I have done it for years and it's never failed me. So what we'll do is we have our wire and we maximize our contact patch, have it protrude just a little bit past the opening. If I go too far, when you put a bolt through, it's going to probably hit the wire and you're not going to get a good flat surface. So you want to make sure this area stays open as possible. That way the fastener can make a good connection. Really crimp it down. So I see a lot of factory connectors, they'll have a little more of a divot, so they're using a die. This is straight vise. And the downside of going straight vise without any solder or anything is if it's not crimped enough, it has the potential of slipping off. So I'm just going to put the ring in there and let's pull on it. So you see that is the potential problem, is it can slip off. So we're going to show you a way to prevent that. Okay, I'm going to do it again. So we already know this is not the optimal way to crimp because it can slide out. So to prevent that, we're going to add solder. Now be careful with the fumes that you can see. You want to breathe in the flux, because this solder that I'm using has flux built into it. And I'll use the vise to heat sink. I want it to cool down. Still a little bit hot. Now when I place in the vise, you see me doing this, people see me in the video, I'm not re-crimping it. I'm just using it to cool it down. Okay. So still a little bit warm, but you can see that the solder on there is not molten anymore. So same test. Crimping it, we're going to pull on it. So we can see now with the solder, it really holds it in. Like, I am honestly trying to pull it out. So it won't come out. That is the trick for me. I've used this for years. I do have these connections still on my truck, but the trick is the solder. In the shop I'm in now, I don't practice this anymore because there are better ways of doing it. There are cleaner ways of doing it. But to me, this is still a solid connection when adding the solder. To me, it's never gonna come out. But as demonstrated before, if you just straight vise crimp it in without using a die, I've seen dies you can use with a hammer as well. I'm not a fan of those. A vise with a die would be much, much better because you need some sort of bite into it. You need to create some sort of tooth. Creating that flat, pure surface works okay. It's better than I've seen where you use the improper size crimp, but obviously not optimal. Okay, moving on to our battery cable now. Now this wire is a lot harder to work with. Good for the end result. Not so great when you're trying to do your connections. There's a few more steps, so sometimes I just take a knife to it after splitting it so it comes apart. So we can see that the strand count, if we compared it to this guy over here, this has way finer thread strands, and this is just way more malleable. So when you're dealing with a lug, it doesn't matter if it's 8 gauge, 4 gauge, 0 gauge, whatever you want, it's gonna be the same thing. So we'll actually have it a little bit longer than it needs to be, and we can always adjust, but I don't just twist it on. We'll actually hit it on something till it goes further in. So I want to squish as much of it into that taper tip as possible. Now once it's done, I like to get this as close to the jack as possible, and you'll find already it's grabbing really well. So it's very important to have the correct gauge on there. Especially with this battery cable, because the wire is so tough, it's impressive how snug it is. You're not done, but the fact that it's quite tight already means we're gonna get a really good crimp out of this. So this application, we're gonna use our hydraulic crimper. This is a great tool because I like if you ever have to make crimps in the car. Like, you can't bring your vise over the car, that's the biggest disadvantage. This can go anywhere, but because it's mobile, I wish it had a flat bottom. This particular one, like, you don't have to spend a lot of money, but this isn't the most ergonomic tool to use because you're trying to hold the wire in place because you want to get it as perfect as you can, and then you're trying to crimp at the same time. So I find if you just lay it on your bench, make sure you pick the correct die size, And then, oops. The other thing you have to be careful with, because this is cast and this hydraulic is pretty strong, once the die has connected, don't keep forcing it because you could accidentally crack on these tools. So we've already began the crimp. So we can see that we have the same shape as the die happening. So it's grabbing it from a lot of different points. So you see the flare there. So you can see the difference in the diameter. You're pretty much done. Like, you could crimp it one more time if you're really worried about it, and keep crimping it so you have that much more material grabbing onto. We see the diameter's changed quite a bit. You could also leave the flare in here because the flare is exact to the jacket. So when we put our shrink tube on, it's going to have a nice smoother transition. So the way it is now, we're going to leave it, and let's just try our tug test again. Now, this isn't a true scientific test because I am using a different kind of wire. I will admit that. But I can already say that that looks a lot better than the ring terminal. Looks more professional. I know it's going to have good current flow because I know that's copper. Some of those ring terminals, you kind of like, is it pot metal? What's the coating on it? Is it actually copper underneath it? You don't know sometimes. And the impressive thing is, you're not squeezing it as much as the other way. Like, if I just crush in the vise, it's flattened in half. And this way, it doesn't come out. Again, granted, the wire is different, but this is a really proven way of crimping. So now I'm going to show you guys what it looks like when we add some shrink tube on it. So we're going to do this with the glue. It is black shrink tube. I know it's a red wire, so if you really want, you can use red. Today we're going to use black. Now, the reason why you want to use a heat gun is because it will slowly and more evenly distribute the heat compared to using a flame. Because if you use a flame on it, you'll get this bubbly look on it. It just doesn't look nearly as good. Heat guns are not expensive. You don't have to use variable heat ones, but you want to get something with some sort of end on it to help concentrate the heat if you're doing wiring. You want something that tapers off so you can really focus it, especially if you're in a vehicle. You don't want just heat going everywhere. You want to focus it on the shrink tube. There, that looks good. Now, what I like to do with this shrink tube with the glue too is sometimes if I'm doing pre-wiring for an amplifier, I'll put the ferrule on my 4 gauge, for example, and then I'll use shrink tube double wall with glue. This will help hold the ferrule in as I'm crimping. If I'm going to use the amplifier set screw to help crimp it on, if I'm not going to pre-crimp it, because sometimes you can't always pre-crimp it because it changes the shape. So using this will help hold it together and also seal it. So now we have a pretty weatherproof connection. The only thing that could happen over time is the copper itself could corrode. That can happen over time, so you want to make sure that you're putting some sort of dielectric grease on and in general keeping it clean. All right, so let's show you guys now the ferrule connections, and we'll show you 2 different means of securing it onto the wire. So this is the largest gauge of wire that goes into my crimper. This is 8 gauge. And the way I like to do is I like to make sure that I can just see the wire come out the end, like, because you actually have to strip it back further than you think. So we know that's going to make as much of a full connection as possible. So we can see it makes a really good looking connection. Now let's just pretend this is an amplifier. Now this is 4 gauge, putting 8 gauge terminal in, but we've done it a lot of times. A lot of jail amps don't need to have 4 gauge all the time. Obviously you want to have thicker wire, but we use this as an example. So when I put the ferrule in, I just don't have it any way. I try to have the flat spot to the set screw. And remember, if it's using a clamp, I don't use these. If it's the set screw, I will. So I'll still crimp it in there because they have a lot of give. I still want it to be snug. Okay, it's snug. Great connection. It's not going to come out. It's not going to arc. What does it look like though? Let's say I had to take it out for some reason. So it still gets crimped, but you see, look at that indentation that the set screw made. See that edge is deeper than the middle? You'll get a really big cutting action going on there. This is why this is becoming so popular in the aftermarket right now. All right, so what if we're dealing with larger gauge wires? This is what I do with 4 gauge, because 4 gauge is probably the most common, straight into an amp. 4 gauge can handle quite a bit of amperage, and if you're doing relatively short runs, for most people, it's going to handle all their power needs. So you see, I did not strip it back far enough. It's in there too far. Like, you could crimp it like this, but why risk it? Because let's say the set screw goes closer to the end. Well, you're not really grabbing much wire in there. It's not going to do you much good. So take the time, double check your work. There, looks a lot better, nice and flush. So we're going to grab our connection again. Back up the screw a bit more. Almost have to back it out all the way. So here, I don't know if you guys can see, but it's wiggling, it's pivoting, but the diameter is pretty much spot on. So depending if you're trying to pre-crimp, if you end up making it go wider, it might not actually go in. So a lot of these amplifier installations, I'll have shrink tube on here, and then we'll go ahead and put the set screw in. So let's go ahead and just put the shrink tube on just so you guys know what that looks like. So in that Camaro, I had to do a bunch of connections and I couldn't crimp anything. So it looked exactly like this. So I just place it on. So you can see it easily comes off. This isn't what we want as a final product, but as we get into the vehicle, this is what we do. So we will, again, if you can get red with glue in it, great. I'm just going to use black because it's got the glue in it. You want to heat it up just so the glue can activate as well. Just because it shrinks doesn't mean the glue's activated. So you want to see it seep out just a little bit on the ends, you know it's working. And then we're going to let it cool down. But now, as I'm working in the vehicle until I'm ready to get it into the amplifier, one, it looks more finished, two, it's helped holding it on there for me. All right, so we have our ferrule in there. It's not going to fall off when we're working. Looks nice and finished. Unused, no crimp. And because we're using quality connection or quality amplifier, so you see this one crimps really well, like it's really soft. The wire is soft. And you'll find just by using that set screw, it's not going to come off. So let's see what it looks like. So made a big indent into it. You see, that's what's giving us our crimp. Like the glue probably helps like a little bit, not much. And let's compare. So in some ways you think, well, if this is perfectly shaped inside the amplifier, it's making a lot of good contact on there compared to, say, this square, because then you're only making contact with the edges mainly, unless it can kind of make it conform here. And then there's the set screw as well making contact. So there's pros and cons to both, but at least you guys can see like, hey, if I crimp it, and then what does it look like inside the amplifier once it's crimped if you don't want to take it out. I really recommend, like, once you guys do it, the install, I wouldn't uninstall it just to see what it looks like. Take the time, make sure the wire's where it needs to be. It's one of those things you just don't want to take in and out all the time. They're not technically designed to work like that. Like, it can, but it's one of those things, like, if you do it properly, you just set it and forget it. Now here's a bit of an oddball situation. Is in the Camaro we had our battery lug, but then it went, so this is a typical outside connection that we do, but then it went into an aftermarket distribution block. So how did we get into that one? And this is really tough, coarse wire. Does not really want to move around or compress. Also, the ferrule, as it increased in size, just seemed a lot tougher. So I didn't really want to rely on just using the set screw. So I had to strip this back quite a bit, and I had to just tap on the ground a few times to make sure it goes flush all the way in. It's already pretty tight, like it's shoved in there, but I do not want to run that set screw. I'll show you guys right here. Now here's a situation where I would crimp for a ferrule. So you see here, this is where the set screw is hitting, and this is 0 gauge, but there's a little bit of play in this particular opening. So you see here is the sizing for this particular unit. So if there's play like this, I don't mind crimping it, even if it flares out a bit, because you can see here, I've crimped on the front and the back to give it a good clamping force, but then the middle I left alone to let the set screw do its thing. And then we can clamp it down, because like I just don't know, because like looking inside, that looks like copper to me. So if you were to, the screw's not copper, so if you just keep cranking as hard as you can on a fresh ferrule with no crimp, hoping that's going to make your crimp, what I'm always scared of is on larger units like this, or larger ferrules like this, I'm afraid of stripping out the threads. So by crimping it, I just snug it in. And I verified, even though this fastener is protruding a lot, it doesn't come anywhere close to the cover. So I don't mind it being like that, because if I tried to really keep screwing it in until it was almost flush, I'm pretty sure I'd strip it out. So those are the situations that I will crimp on a ferrule. Very rare, because on a 4 gauge, the metal's a lot softer. I'm not dealing with the battery cables, the strands are finer, it compresses a lot easier. On a 4 gauge, I'll just crimp this down, they don't come out. But when I'm dealing with large, coarse threads in here, and the ferrule itself is fairly stiff, that's the good time to crimp these. So yeah, I was worried that, okay, that looks like copper, it might be a softer metal. I don't want to purchase another distribution center. So what can I do to make sure that this thing has a bit of a crimp, but at the same time get that set screw mark that you saw earlier? So what I did was, because it's so long, we would use the hydraulic crimper. Now, this is what I used for the lug. We're gonna see if the die will work. If it's too big, not a big deal. We can always size down. So it's pretty much hitting, I'm barely crimping it. So we're gonna have to change the die size on this. Okay, we've changed out our die. So I went all the way to the installation, and we're gonna go ahead and make our first crimp. Remember, this works because there's play in the part I'm hooking into. So you can see, honestly, that'd probably be enough. You see how nice that looks? But this is what I did, was then I only put just the tip in. So I'm going to reproduce what we did on the Camaro. So you see guys there. So I'm leaving a bunch of it not in the crimper. Once I feel a lot of tension, I back off and I just apply a little bit. So kind of what we produced there, but then what I did was I set the set screw first, and then I kind of knew where it was placed, and then I would change it. So back here we can't do much changing it, but we can maybe do less or more in the front. You could do the whole thing based on how it went in for that particular distribution block, but you know, you have options again. Like, there are just different ways of doing things. So let's see what it looks like if we just do the whole thing. Looks really good, very professional looking. These particular crimpers, like, they're not much. They're like $100 or less. You buy them online. I didn't line it up exactly, but like if you're doing it all in one shot, you just do it in 2 crimps. But that's not gonna go anywhere. But like I said before, like this technique will work if you have a large variance for the diameter it's going into. If it's perfectly cylindrical, well, now it's wider, it's probably not going to go in. So this technique won't work, but you can see that the products will change, and then you just change and adapt with it. Now here's the final connection that I actually do quite often in the shop. It's 8 gauge to 8 gauge. And you're like, when do I ever have to do that besides a fuse holder or distribution center? Well, if you're working with product that's a self-powered amp and sub, for example, it's all built into one enclosure. There's usually a plug and it'll have pigtails coming off it, and it's typically 10 to 8 gauge wire, but it's only a pigtail. It's not enough to run all the way to the battery, or long enough that you can cut it and then put a fuse in line. So if you have a wire coming off your amplifier built in, and it's only this long, and then you have aftermarket wiring, well, how do you connect it? We're going to use a butt connector. We're going to show you a different way of using it, and then we're going to get away from soldering, because a lot of people will, and you can solder 8 gauge, put shrink tube on it, tape it up. It will work. It's not the best, and it doesn't look good. So we take this butt connector here, I had to persuade this one a bit differently. So we use a variety of crimpers in the shop, and I find for this application, ones with a tooth work best. Now this is where people will make the mistake. They'll grab a crimper that is designed for the wrong gauge, and this is where you get an ugly look out of it. This particular crimper is just, this connection is just way too big for it. It'll work, but if you get the appropriate crimper, it's going to do a better job of making our connection. Now on other butt connectors, there's a seam you have to worry about, so don't put the tooth on the seam. This one doesn't have it. So I'm just going to go on the opposite of the mark. I'm going to push down, use my bench. So crimping it, there's nothing wrong with that. It's actually really tough. Doesn't want to come apart. I like the look of this more than just, twisting together or fraying them out and meshing them together and then soldering it, which will work, but then it's technically more brittle whenever we solder, and also it'll increase the diameter. So you can see here, the diameter is pretty much the same as the jacket. You just have to finish it off. So here's our connection. So really good, looks really good, clean, professional looking, nice and strong. It's not gonna come apart, set and forget it. As you guys can see, there is a variety of ways of making connections to your devices, to your battery, in order to make it look good and last a very long time. If done properly, using proper connectors, items like dielectric grease, proper tools, you will make connections that will last pretty much longer than the rest of the vehicle.